Often, the most important lessons we learn are what not to do. Today, we'll be talking about bad Python code and Python anti-patterns with Andreas Dewes. It's show number 18, recorded Thursday, July 1st, 2015.
I'm a developer in many senses of the word, cause I make these applications, but I also use these verbs to make this music. I construct it line by line, just like when I'm coding another software design. In both cases, it's about design patterns. Anyone can get the job done, it's the execution that matters. I have many interests, sometimes it can...
Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter. I'm at mkennedy. Keep up with the show and listen to past episodes at talkpythontome.com, and follow us on Twitter where we're at TalkPython. This episode, we'll be talking to Andreas Dewes from Quantified Code about Python anti-patterns. This episode is brought to you by CodeShip and Hired. Thank them for supporting the show on Twitter via @CodeShip and @Hired_HQ. I don't have any major news for you this week, so let me introduce Andreas so we can get right to the show. Andreas is a physicist and software developer with a passion for code quality. He leads the development of algorithms and software at Quantified Code. Andreas, welcome to the show.
Thanks. Thanks for having me here.
Oh, it's great to have you here. We're going to talk about design patterns, both good design patterns and bad design patterns or anti-patterns, with the stuff you guys have going on at Quantified Code.
Exactly. Yeah.
So you've built a bunch of awesome tools, both visual and static analysis, and we're going to talk about that. But before we get into it, let's just take a step back down memory lane and, tell everyone how you got started in Python and programming and what's your story? How'd you get here?
So my background is actually not in software development, but in physics. And I made my first contact with Python while I was doing my PhD, which was about experimental quantum computing. So we did experiments with microwaves and lots of signal processing. And when I arrived at our lab, we had a lot of equipment that we needed to control using programs, and we had a lot of data that we needed to analyze, to visualize, and to process. And we did that using various programming languages, for example, MATLAB and C and C++. And we were also using tools like LabVIEW that help you to define interfaces, graphical user things, and control your measurement equipment. And I remember when I came to the lab, this was basically a huge mess because we used 4 different programming languages, and the graphical programming interface of LabVIEW, which is nice in principle, but which makes it really, really difficult to write complex software systems with that. And so I said, hey, there has to be a better way to do this. And one of our postdocs, he used Python in his job in the US, and he introduced me to it. And so I started getting interested in that, and I tried to replace more and more of our software stack with Python. And after about 1 year or half a year, I think we had replaced most of the data acquisition and data analysis things we had in the lab with Python programs. So, and that was kind of the first contact with that language. And also when I, that, I saw that it's really powerful, and you can basically do anything with it. And yeah.
Yeah, that's great. I think a lot of people come to Python for the data science component of it. And I think, like you were saying, the fact that it's a full stack, legitimate end-to-end programming language means you don't have to just live within these little shells of what MATLAB will do or LabVIEW will do, but you can bring it all together.
Yes, exactly. Yeah. And I mean, back in 2009, when I started using it, the tooling was already pretty good. But if you have a look at it now in 2015, it's really amazing what kind of an ecosystem people have created, with, for example, the IPython notebook, NumPy, SciPy, and all these other tools that we can use to, as you say, do almost anything that we can imagine. So it's really, really amazing to see.
Yeah, it is really amazing, and it's great. And I think the thing that, among other things, that surprises me is it's free. You look at MATLAB and Mathematica, you pay tons of money to be locked into these somewhat confusing.
Yeah, exactly. And it's the power of open source. So I think,
you're doing all this cool programming and getting into Python for your work at Quantified Code. This is a company you co-founded. Who did you co-found it with, and what do you guys do there?
So I co-founded it with an old friend of mine, and we're doing static code analysis for Python, but also other programming languages. And the reason we started this company was that I saw during my PhD that, hey, it's really hard to write good software because I didn't have a background in software development. So I wrote lots of very, very bad code and I made a lot of mistakes. And I thought it would be really nice to have like a system, an automated system that would tell me how to write good code. So that's when I got interested in all these things like static code analysis, and I started looking into what kind of tools existed for Python and other languages. And I found that most of the tools that we're using today are still not good enough, or they could be much better. And so that's kind of our mission, to like make these tools much better and allow anyone to like have access to really high quality, state-of-the-art code analysis.
Yeah, that's great. One of the problems with a lot of static code analysis is it's very good at finding the small rules, like, hey, you should have white space between these things. You should have a new line here. Your line shouldn't be this long. Your variable should be named this way.
Yeah, exactly.
But that's like the stuff that robots can do, you know? Mm-hmm. The stuff that's really valuable is the hard-learned lessons of, if you write your code this way, it's easier to maintain. If you write your code that way, it will actually run faster, or it'll be less error-prone. And that's normally what you get by working with kind of a mentoring apprenticeship, you know, working in a team. But it's also the whole concept of design patterns, right?
Yes, exactly. I mean, design patterns certainly help people to become productive and to use solutions that are battle proven, so to say, and tested in the field. I mean, a design pattern in that sense is just like a reusable solution that you can take and implement in your own code. And I mean, I wasn't even aware of that, but I also made use of design patterns, which I copied like from the internet for the work I did during my PhD. I used, for example, the observer pattern and the command pattern and other things, which I just like intuitively could adapt to my own needs and use in my projects. And the great thing about this is also that it gives you like a common language to talk to other people with, you know, because if you say, hey, I got this class which is like receiving a notification from this other class, and then it's doing some things, I mean, it's okay, but you could just say, hey, I'm using this observer class, and then everyone kind of knows what you mean, you know?
Yeah, I think that is one of the absolute really strong powers of design patterns. Obviously, one is to know the solutions, but the other is to have larger building blocks as you think about your application mentally.
Yes, yeah, exactly. Yeah.
All right, like you say, if I go to you and I describe, okay, what I'm going to do is I'm going to have a variable, and the variable is going to be shared. There's only going to be one of them, and it's going to be shared across all parts of the application. And so when one part changes it, the other part will see that same change. I could have this conversation, or I could just say, I'm using the singleton pattern.
Yes, exactly. Yeah.
You know what I'm talking about. You know what the positive side of that is. You know what the negative side of that is. You know singleton pattern is a challenge for unit testing. And so is that a trade-off you want to make? And it's not just helpful for working in a team. I can tell you that. You could tell me that. But I think it's also helpful just for you internally as you think about how your code is structured.
Mm-hmm. Yeah, absolutely. Yeah.
We've all written a lot of code, and we may or may have not given it good attention. We may have written it bad. We may have written it well. We might have been in a hurry. And so, or, you know, much more common, we've gotten it from somebody else. And we have to deal with it. And I think understanding these design patterns is really interesting, but also understanding when they're needed. And so there's this related idea of this concept called code smells. I think it was introduced by Martin Fowler, but I'm not entirely sure. Are you familiar with it?
Yes, it's possible, yeah. I'm not 100% sure. I mean, design patterns has been introduced by this gang of four in 1994, but I'm not sure where the term code smell comes from, yeah.
Yeah, certainly Martin Fowler wrote a lot about it. And I think it's a very interesting way to think of things, you know. So I'll put a link to some code smells in the show notes. And I think kind of what your code does is it sort of looks for code smells. It says you're doing these things that are not necessarily going to make your code not run, but it's not the best way to do it.
Yes, exactly. I mean, what a static code analyzer does is basically that it looks for patterns in the code that can either produce bugs or are quality problems of the code. And so for us, like code smell can be categorized by how severe it is. So it might make your code crash, or it might just be an annoyance to another programmer who takes longer to understand the code. And also by various categories like does it affect the performance, does it affect the security of the code, does it affect the maintainability. So there are lots of different types of code smells in that sense.
Yeah, and if you think back of just thinking of the code smells that I can remember, there's some good ones like duplicated code.
Oh yeah, that's
that one's common, right?
Yes.
Or feature envy, or long method, or there's a bunch of too many parameters.
Yes, I mean this we're seeing a lot in the code. We analyze very complex functions with a lot of parameters that have too many responsibilities and are really hard to understand. So, I mean, I think that's really the number one performance or maintainability killer today in software, complexity.
I agree. One of the really interesting code smells, I think, are comments. And so you think, comments, I'm supposed to comment my code. That's a good thing. A lot of times, programmers will use comments where they should have just written better code.
Yes, exactly.
They'll write a function that has a bad name and it's not well written, so it's hard to understand. And then they'll put a nice little comment to describe what it does because it's not well written. Where the real fix would be to write to refactor it to have a proper descriptive name and to be cleaner in smaller parts, right?
Yeah, absolutely.
Yeah. Comments are kind of like deodorant for code smells, right?
That's a good comparison. Yeah.
Okay, so. That brings us to how I kind of got connected to you guys or learned about you guys is through this thing you wrote called The Little Book of Python Anti-Patterns.
Mm-hmm. Yes.
Can you tell us about that?
Yeah, sure. So this was a project we started because we wanted to get an overview of what problems you would find in Python code. And so we started collecting problem types and code smells and issues from different sources. For example, lints like Pylint or PyFlakes that already have like a collection of a few hundred of those anti-patterns. But also from sources such as Stack Overflow and articles, blog posts, and also from people and from code that we were reading. And so we collected all this together, and then we worked with a freelancer in the beginning who helped us write a large part of the initial text, and we bundled this whole collection of anti-patterns together into a book so that people could just learn about different things they should avoid in their Python code. So it's not like learning from good code, but learning from bad code in this sense.
Yeah, it's related to that code smells idea. I see all these problems, and if I know to avoid them, well, either you know the right design pattern and the right style, or you just know you need to go do some research and don't do it this way.
Yeah, exactly.
Yeah. In your book, you do have sort of recommendations for most of the anti-patterns, right?
Mm-hmm. Yes. So if we describe the problem, we always try to give at least one or two solutions to it. I mean, sometimes there is no really unique solutions, or people would kind of disagree if it is a problem at all or not. So, but we are always pretty opinionated, and we think a good programmer should be a bit opinionated, and so we try to give our solution that we would actually solve the problem with.
Yeah, that's great. And let me just tell everybody that the book is at docs.quantifiedcode.com/python-code-patterns. And of course, I'll put that in the show notes as well.
Yes, that would be great. I mean, we also have GitHub repository, and the whole book is open source, released under a Creative Commons license. So we're always happy to see contributions, and so if people are interested, they would be very welcome to contribute.
Yeah, that's excellent. Let me pull this up here. So in your book, you've broken it into, quick math, 6 sections. You sort of categorize the problems that people run into. One of them is correctness. One is maintainability. Maintainability is one that catches up with you later. Readability, security, performance, and then you have a special section on Django.
Yes, exactly. Yeah. So yeah, I mean, as I said before, we tried to just categorize the issues or anti-patterns so that people could go through individual sections and, for example, see what type of problems really affect the correctness of their program and what type of anti-patterns only affect, for example, readability or the performance.
So let's maybe look at a couple of them. I'll just sort of scan through here and just tell people the kind of stuff that's in there.
Sure.
One that I think is somewhat common when you're new to programming in Python is this one you call bad except clauses order. Can you talk about that?
Yeah, so bad except clauses order basically means that you put an except statement, that you have, so to say, a sequence of multiple except statements where the first one of those statements is already more generic or general than the second one. So basically your second except clause will never get executed. And that's kind of really easy to get wrong. It also happens to me a lot.
Yeah, it's not obvious, especially if you're going back and adding these additional except clauses. So maybe you say try, you're going to do some code, and then you say except exception as X, and then except type error as TE, right? That type error will never get run because the exception is the base class of type error.
Even worse than this pattern is probably an empty except block without also an exception type. I think that's kind of the most evil Python anti-pattern that exists.
This episode is brought to you by CodeShip. CodeShip has launched organizations, create teams, set permissions for specific team members, and improve collaboration in your continuous delivery workflow. Maintain centralized control over your organization's projects and teams with CodeShip's new organizations plan. And as Talk Python listeners, you can save 20% off any premium plan for the next 3 months. Just use the code TALKPython, all caps, no spaces. Check them out at codeship.com and tell them thanks for supporting the show on Twitter where they're at CodeShip.
And I have to admit, sometimes I use it, but it's really bad because it swallows up all your exceptions and it doesn't give you any useful information about what happens in your code. So
yeah, maybe if you're lucky, the empty except clause at least has like a logging statement.
Yeah, that's
or something
already good. Yeah,
but if you have, but if it has except pass, that's
really
pretty
evil.
bad.
Yeah, I spent many hours debugging stuff like this. Yeah. Most of the time I wrote them myself, but
yeah, I like to think of that one as the intern clause.
Yes.
Because they're like, oh, this isn't working. Oh, I can just put this in here and my code is now reliable. I'll be out of here in 3 months. Let's see. There's some other interesting ones. Under future import is not the first non-docstring statement. What's the problem with that?
Yeah, so this is just a convention of the Python interpreter because you can use these so-called future imports to import functionality that is usually not available in your Python version. For example, one thing that is often used are absolute imports. And the thing with the future imports is that you have to they have to be the first statement in your file. So you cannot like have autocode and then afterwards a future import because the Python interpreter needs to load these ones right at the beginning. So I mean, this is kind of an easy pattern to catch, but still sometimes it happens that you have this in your code. But I mean, it's also something that you would notice really easily because your program wouldn't run even.
Yeah, for sure. Another one that you can tell that people are coming from somewhere else and they haven't quite fully gotten the Pythonic idiomatic style is implementing Java style or C++ style getters and setters.
Oh, yeah. I like this one a lot. We also see it often in our analysis. And so this is basically when you write set something and get something function in a class, which you would do in Java, whereas in Python, the appropriate or the correct way to do this would be to use so-called class properties, where you can just have just access an attribute of a class using a function which looks like an attribute access, so to say.
Right. Just use the property decorator. Yeah.
Yes. Exactly. Yeah.
Yeah. Then there's others that are less obvious to me. One of them is if I'm not using the default dict. What's the story of that one?
Oh, so this is more a recommendation than a real anti-pattern. But I mean, Python has these great collections library, which contains many data structures that can help you to make your code easier to understand. And the default dict is one of them, and it's one of my favorite ones, and the one I probably use most in my code. And what it is a dictionary that basically initializes the value of a given key to something that you can pass in as a function. So the typical use case for this would be that you have a dictionary with a list inside. And so if you like want to create an entry for some key that you haven't seen before, normally what you would need to do is to check if the key has been set in the dictionary before. And if not, create a list, an empty list in that place, and then append the element to that list.
Yeah, so it's like 3 or 4 lines of code, right?
But the default dictionary basically does, yes, so that's 4 lines of code, and the default dictionary basically does that for you, because you can just say default dict of list, and then whenever you will like access a given value for a key in the dictionary, it will have created an empty list if there has been no value in it already. So really, really useful. And I did not know this when I started writing Python, but it really makes your code much more readable. So.
Right. Does that come from the collections module? Default dict?
Yes, exactly. Yeah.
Yeah. So it's not immediately imported, but it's easy to get to.
Mm-hmm. Yes, it's in the standard library. Yeah.
So another one that you have, let's move on to the next section of maintainability. And one of them, I think, is probably pretty common, is you should not be using wildcard imports. So from
yes.
math import star. It's so much easier to type. Why shouldn't I just do that all the time?
Yeah, that's also a mistake which I made like a lot in the beginning when I started writing Python code. And it's pretty insidious, because normally it doesn't break anything, but in some circumstances you can override functions that you have imported before, and so the behavior of your program changes in like really unexpected ways, I would say. And so today I always try to use only qualified imports, so either import the module and then use it as a name when I access the variable, or explicitly name the things that I import from a module.
Yeah, I'm with you on that. I try to, if it's not too much writing, try to use the name so it's really clear where the type is coming from. But sometimes, it's like, well, I'm
yeah, I know it. I do it sometimes too. Yeah.
But more as like an explicit import. So another area that you guys did a lot of work on was readability.
Mm-hmm.
And I think one of the ones that's, I don't know how easy this is for your system to check automatically, but certainly if you come from a language like Java or C# or C++, is not in your way of thinking, right? Even though it's one of the core tenets of Python, and that's ask for permission instead of for forgiveness. Asking for permission is the anti-pattern rather than
yes,
for
exactly.
forgiveness. Yeah? Can you tell people about that?
So usually when you write Python code, the preferred way is to like assume that everything will go as you expect and not perform any checks, but rather catch an exception if some part of your program throws one, and like handle that exception, and then react to like behavior which you didn't anticipate, so to say. A good example is always like when you're opening a file, you could think of like checking if the path exists, and then open the file at the path. But I mean, between the two calls, like check of existence of the file and the opening, there could actually happen stuff, and so your program could still crash, and you will have an exception handler for that then. So the preferred way here is to just assume that the file is there and try to open it, and if you get an error because the file does not exist or something else is wrong, then handle that exception, so to say.
Yeah, I think that's pretty key. Another example is just, you're trying to think of all the use cases of how something could go bad, and you end up with like 5 or 6 if tests, and then finally you're going to actually perform the thing, and you may have forgotten one of those, or there may be something else. So imagine I'm going to call a web service.
Yeah, exactly.
I got to make sure the network is on. I got to make sure that the address is well formed. And then, I got to make sure my data I'm going to send it is well formed. And then it still may be the case that the DNS name doesn't look up. Just there's so many things that could go wrong. Just try it, and somewhere higher up where it makes sense, catch it and handle it, right?
Yeah.
That's what you're recommending there.
Another thing which I did quite often in the beginning when I learned Python was to use, for example, the non variable to like indicate like a special that something happened inside a function. For example, that something didn't exist and the function couldn't do what it was supposed to do, and then basically check for this non value in the code that called the function. And this, of course, makes it also very complicated to like handle these kind of errors, because now the function does not return only one type of value, but two different ones, like none, for example, and like a numerical value or something. And that's also a very good case where you could like ask for forgiveness instead of permission by just like having a function that throws an exception when something goes wrong, and then catch that exception in the calling block of the function instead of like looking for a magic non-value or something.
Right. And the thing about that is that complexity that you're adding by having a return of none or a real value or some sentinel value that is indicating the wrong value means you propagate that complexity up through the callers, and then it propagates up higher.
Exactly.
It's not just your little function that's harder. It's like you force this style onto everybody up the chain. That's bad.
Yeah.
So another one that you have that I think is pretty common for people who are new to Python, but quickly they get over it, is using an unpythonic loop or a non-Pythonic loop. What's a non-Pythonic loop for the listeners?
So, I mean, many people, me included, that come, for example, from like a C background, they're used to writing loops where they initialize some loop variable like x. They set them to 0. Then they increase the value of that variable to, for example, the length of an array. And inside the loop, they then fetch the value of the array element using the index operator, so to say. And in Python, of course, you can just like iterate directly over a list, for example, and not use a range to like first get the indices of the list and then only retrieve the value of it inside the loop. I mean, this is only a small thing, but it also makes your code much more readable, and it like helps you to avoid errors because it involves less variables and less things that can go wrong, so to say.
Yeah, that makes a lot of sense. So the next section, security, is actually pretty simple.
Yes, I have to say we have to work on the security section, because right now we only have, I think, one entry, which is the use of exec. And in our analysis tool, we flag that by default because it's not always an anti-pattern or something that you should avoid. But it's, of course, a huge opening in your system, and it can like be used easily to like execute like untrusted code. So I think it's not in general an anti-pattern, but if you use it, you should definitely be really careful with it and like think a lot about which code or which things you're passing into exec.
Yeah, absolutely.
Because unfortunately, Python does not have a real sandbox as well, a safe sandbox. So, I mean, there are some things that you can do to make it a bit more safe to use exec, but there's nothing that can prove like 100% security in that case.
Yeah, to a large degree, it comes down to how much do you trust that string input that you're passing there, right?
Yes, exactly. Yeah.
And if it's entered into a community forum, it probably shouldn't be exec.
Mm-hmm. Yes.
it would be the
I think so, yeah.
basically the Python equivalent of a SQL injection attack.
Yes.
Something to that effect. Okay, some other ones that were interesting in your performance area. You have one using key and list to check if key is contained in a list. What's the story of that one?
Mm-hmm. Yeah, I have to say the performance section is also pretty small right now, but this pattern has to do with the complexity or the computational complexity of an operation. Because if you, for example, try to find out if a certain value is in a long list, in our example, we have, for example, a list of several numbers, and you want to find out if, for example, 3 is in that list, then the code that checks this will have a linear runtime, so it will take longer the longer the list is, so to say. And if you would use a dict instead, where you have like just a mapping between the values that you have in the list and a true value, for example, then you could like perform the same check in constant time, so order of 1. And I mean, this is also like a small thing, but if you have really long, large data structures, which, for example, I had in my PhD when analyzing data, this can make a huge difference in the runtime.
You're right. It can make a tremendous difference. I'll tell you a real-world story where this completely changed my perspective on this. This episode is brought to you by Hired. Hired is a two-sided, curated marketplace that connects the world's knowledge workers to the best opportunities. Each offer you receive has salary and equity presented right up front, and you can view the offers to accept or reject them before you even talk to the company. Typically, candidates receive 5 or more offers in just the first week, and there are no obligations, ever. Sounds pretty awesome, doesn't it? Well, did I mention there's a signing bonus? Everyone who accepts a job from Hired gets a $2,000 signing bonus, and as Talk Python listeners, it gets way sweeter. Use the link hired.com/talkpython and Hired will double the signing bonus to $4,000. Opportunities knocking. Visit hired.com/talkpython and answer the call. I was working on this project involving eye tracking, like not the letter I, but where you're looking. Mm-hmm. And this eye tracking system was collecting data at 250 hertz, so 250 times a second. And we were trying to do real-time analysis on this, which meant we had 4 milliseconds between the times that sample came in. Right? It had to really be quick and efficient. Yeah. And we were doing some stuff that we had ported over from MATLAB, and we were doing basically what you said. We had kind of this running buffer of data, and we would have to seek back into it and find certain elements, and then we would apply that forward over a certain amount of time. And we ran it, and the code was too slow. We're like, oh no, it's too slow. If we can't make it go 4 milliseconds, it's not going to be real time. It's just that simple, right? Mm-hmm. And so there was just tons of complicated math, and I'm like, we really don't want to try to optimize that. We're like, it's like wavelet decomposition, and so it was on the very edge of even understanding the math, and so optimizing it was a bad idea. And after running some performance analysis, profiling stuff on the code, it turned out 80% of the time was spent looking for an item in the list.
Oh, I see.
So we got it to go 5 times faster by switching to a dictionary, and it was basic.
That's great. That's a quick win. Yeah.
So little work, and we got to avoid optimizing wavelet decomposition math, which is fantastic.
Mm-hmm. That's awesome.
Yeah. So it sounds really simple.
Yeah, no, that's a perfect example. I mean, small things can make a big difference. Yeah.
Yeah, they sure can. That's cool. The last section is Django, and I'm more of a micro-framework guy. I haven't done a lot of Django. Probably have a show on that coming up at some point, but maybe you could talk about some of the highlights there for us.
Yeah, so we added a Django section so that a lot of people were using the project. I mean, a lot of the Python projects out there are web projects using Django or Flask or something else. And so we wanted to help people also not only writing better Python code in general, but also getting more proficient at libraries like Django or Flask or anything else. And so the Django section is basically organized in the same way as the main section. So we have maintainability, security, correctness, etc. And the only difference is that we are only talking about stuff that is really specific to the Django framework. So we're telling you how to import modules, how to use a certain field in models, which variables you should have in your config and which variables should not have in your config under some conditions. And also something that is really helpful to many people is we show you which things you would need to change actually in your code if, for example, you wanted to migrate from Django 1.6 to Django 1.8.
Right. Oh, that's really helpful. There's a lot of stuff in there that's non-obvious, and I think a lot of people learn Django by going to the tutorial and going through it and go, now I know Django.
Yeah, exactly. So, I mean, Django is changing really fast. I mean, the community is really awesome, and they're putting out a lot of new features and new versions. And I think, it's good to have this resource where you can see what has changed and how you would need to change your code in order to make it work with the latest version. And I mean, normally you want to be on the latest version because it's more secure and more features and probably better than the precedent one.
Yeah, definitely. When you're running a website, you definitely want to stay on the latest version of your framework.
Mm-hmm, exactly.
Okay, so this project, the book you said is on GitHub, and your general GitHub is just, it's github.com/quantified code, all lowercase, yeah?
Mm-hmm, exactly.
Yeah, so something I found up there when I went to check out your anti-patterns project on GitHub was you also have this thing called a repository called Ex Machina.
Yeah, okay.
That's pretty cool. Can you tell just people really briefly what that is? It looks awesome.
So I have to say this is something that my co-founder Christoph did, because in the movie Ex Machina there's a snippet of Python code that you can see on the screen, and he just wrote down the code because he was interested in what it would do, and it actually prints out an ISBN number of a book that is mentioned in the movie. And he also ran it through our static analysis software, and he found that actually it's not like PEP 8 compliant, and there's some other things in it. So it probably shouldn't be security code, which it was in the movie.
Sure. Well, the fact that you can take code from a movie and it even runs is already
yes,
good.
Yeah, it's
good
great.
deal.
Yeah. I mean, it's really good to see. Awesome to see that Python is used in movies now. So.
Yeah. Ex Machina looks really cool. I have not seen it yet, but
great movie. I would like to talk about it, but I don't want to say any spoilers. So.
Oh yeah. I'll put a link to the trailer on YouTube in the show notes for everyone. They can check it out and go see it for themselves. Awesome. So another thing that you guys have up there is something called Code is Beautiful. What's the story with that?
Exactly. So at Quantified Code, we don't only do code analysis, but we're also thinking about new or better ways to visualize code. Because for us, dealing with a large code base is always involves getting an overview of the whole thing and seeing where, for example, problems are or where work would need to be done. And so visualizing the code is a great way to do that. And we always like things for example, Cityscape visualizations, but we didn't find anything that was open source or available to the public, so to say. And that's why we said, hey, let's develop some cool visualizations of Python code and give them for free to the community. So we started this open source project, and we have currently 3 different visualizations of source code. One is a Cityscape visualization, which is a 3D version of your code where you can, so to say, zoom in and see at a glance where, for example, the most complex part of your code are.
That's really cool. And you should point out to people that it's live. You can rotate it and hover over these they look like buildings or skyscrapers, and it'll tell you what segment of your code that is. What do the colors mean in your visualizations?
So in the visualization, currently the color encodes the complexity on the code. So it's basically the cyclomatic complexity divided by the number of lines.
That is fantastic.
So the cyclomatic complexity is just the amount of the number of branches in the code, so to say. It's roughly, you can think of it like the number of unit tests you would need to test a given piece of code.
Right. How many decision points are there in a given function or class
exactly.
or something like that? So I can create this cool cityscape, and the red buildings are more bad. And if I'm going to look at somebody's code, I guess maybe looking at the height and width of a building also tells me how much is sort of monolithic.
So the area is the area is the number of lines in a given file, and the height is just the total complexity of the file. So
okay. Yeah. Very cool. And then you also have 2 other visualizations that are, I would say, more standard.
Yes. So they're 2D, a bit more down-to-earth visualizations. And we have them because many browsers still don't support WebGL, and we wanted to have something that everyone can use, so to say.
Right. And they're all interactive with D3, right? So you can sort of explore them and so on.
Yeah, exactly. And they're also open source, so you can download them on GitHub, use them in your own projects, and modify them.
Excellent. Yeah, you have a live demo that people can go check out, right? And what are you analyzing? Are you analyzing Django there, or what are you analyzing?
Oh, we have a lot of projects on our platform, about 10,000 public GitHub projects that we constantly analyze. And you can basically go there and see if your project has any problems or if you could improve anything. And you can also get visualizations of all the popular Python projects there.
Oh, that's awesome. Is there a way to hook that visualization into a continuous integration story? So every time I push to a branch, a build is kicked off and then an analysis is kicked off and saved. Have you guys done this?
Oh, yeah, you can do that. You can just sign up for free on our website, and you can add your GitHub project. And every time you will make a commit, we will analyze your project, and then you can get the visualizations on our website. So, and it's of course free for open source projects.
Yeah, that's really cool. So that's quantifiedcode.com. Yeah, very nice. Yeah, I really like what you guys are doing there with that one.
Thanks.
Yeah. So I have a few more questions before we call it a show. One is, what are the worst anti-patterns that you see? Like, we went through a couple of them, but are there some that you go, oh my gosh, if you do this, then it's really bad?
So, I mean, as I said before, the empty try except statement is one of the worst things to debug, I think. And apart from that, I think it's not the simple anti-patterns that are like killing software projects. It's mostly like complexity and like changing code too fast and without having a solid idea of what you're doing and without like writing unit tests. So I think there's no really easy recipe to say, okay, if you avoid this and this and this, then you will write very good code. But I think it's like mostly about like controlling your complexity and like constantly thinking about your code structure and thinking how you can improve it, and also discussing it with other people and doing manual code reviews and automated code reviews. So yeah, for me, it's like as a software development, our daily job is to fight complexity.
Yeah, I think you're right. One of the problems that people end up with is they end up with complex, high cyclomatic complexity and all that given to them. And then they're like, well, if I had written this, it would be beautiful. But of course, I didn't. And so now what do? I'm kind of lost. So 2 books, other than just using your tools to understand it, 2 books I'd like to recommend to people. One is called Refactoring the Patterns by Joshua Kersavsky. Probably destroyed his name. Sorry about that, Joshua. But that's a really cool book of how I take like monolithic, ugly code and like make it better. And the other one is a book by...
I can really recommend it.
Yeah. Do you know the book?
Mm-hmm. Yeah, it's great.
It's a good one. The other one is Working Effectively with Legacy Code by Michael Feathers, which shows you how to take huge monolithic code and slowly break it into more maintainable pieces without breaking it, while keeping it running, basically. So those are some good things to check out if you're interested.
There's also Clean Code. I just don't remember the name of the author right now. I don't know. Do you remember?
Robert C. Martin.
Yes. Okay.
Uncle Bob. Sometimes he goes as.
Yeah. So that's also a great resource, not specifically in refactoring, but more generally in how to write good code. And it's mostly written for Java, but it contains so much wisdom. I think I read it like 5 times already. So, and every time I learned something new. Yeah,
he did a really good book there, and I believe he might have written that with his son Micah as well. So there might be 2 authors, but it's very cool. All right, Andreas, this has been a really interesting conversation. Before I let you off the hook,
thanks for the invitation. Yeah.
You bet. Before I let you off the hook, there's a couple of thoughts and questions I have for you.
Mm-hmm, sure.
One, what's your there's a bunch of PyPI packages and libraries out there in the world. Do you have any favorites that you'd like to recommend to people?
Mm-hmm. So right now I use SQL Alchemy a lot, and I think it's really, really a great Python package. It's perfectly documented, and it allows you to do so much magic with SQL, and it has saved us so much time. So it's really, really a great project, and if you're working with SQL databases, you should have a look at that, definitely.
I totally agree. If I'm working with a relational database, I wouldn't use anything else, basically. That's how I feel about it, right? We actually had Mike Bayer on show 5 to talk about as well. And so that, if people are listening now and they want to go get more info on it, we've got a whole show there. That's awesome.
Yeah.
And what's your favorite editor?
I mostly use Sublime Text, I have to say. But I'm not even a power user, so I'm pretty old-fashioned, and sometimes I also use Vim to edit my code, but I really don't use many key combinations or so. So I'm really, when it comes to developing, writing code,
Yeah, cool. Okay, excellent. Yeah, Sublime is great. So have you thought about selling an ebook version of your little book of anti-patterns?
Oh, I mean, right now we really don't see this as a commercial project, and we just want to make this available to as many people as possible. That's why we license it using a Creative Commons license. So basically you can download it, modify it, and do whatever you want with it. So, and right now I think we don't have a time to make an ebook version, but if somebody would want to do it, he or she could do it.
Excellent. Yeah. Seems like you could write a cool script that would generate a little EPUB or something you could throw into your Kindle.
Yeah. Yes, I think the documentation Swings also supports EPUB and Mobi outputs, so I think it would be pretty easy to do.
Oh yeah,
Swings
cool.
is another good package which I could recommend, by the way, if you're writing documentation.
Yeah, that's what's powering your docs in your book. Great.
Yeah.
Okay, and then why don't you just tell us a little bit about what you guys do at Quantified Code so people can check out whatever you're up to in your day job.
So, I mean, at Quantified Code, what we're doing now is mostly static code analysis. But what our big vision is, so to say, is to change the way that people write software. Because we think that today we're still using tools that are very similar to the ones that we used like 30 years ago. We're like still entering text using editors, and we're thinking of code as text files, and we're like not making use of all the progress in software development and computer hardware as well that has been made in the last 30 years. And so our mission is kind of like to think about new ways to interact with code, to analyze code, and to transform it, and to also make use of all the available data that is out there, because today most of us develop software using version control systems like Git, etc. And those systems, they generate like an amazing amount of data about every interaction we have with a code base. And we can make use of that and like basically use that data to find out how you can become a better programmer, how you can be more effective at your job, how you can be more happy maybe, and how you can write code that is more robust, And so this is basically what we're trying to do. And the first step on this way is, so to say, to develop a new way to do code analysis and help people to like avoid some of the most problematic things in their code.
That's really a great vision and a mission, and you guys are off to a good start.
Thanks.
Cool. Yeah, of course.
It will take a while until we get there, I guess. But I mean, somebody should do it.
Yeah, if you're going to change the world and no one else is doing it, maybe that's you, right? That's awesome. Okay, maybe, well, Andreas, thank you so much for being on the show. It's been great to talk.
Yeah, thanks for having me. It was really great,
Yeah, you bet. It's been great to talk about bad code with you.
Thanks.
All right. See you later.
See you. Bye-bye.
This has been another episode of Talk Python to Me. Today's guest was Andreas Dewes, and this episode has been sponsored by CodeShip and Hired. Thank you guys for supporting the show. Check out CodeShip at codeship.com and thank them on Twitter via @CodeShip. Don't forget the discount for listeners. It's easy. Talk Python, all caps, no spaces. Hired wants to help you find your next big thing. Visit hired.com/talkpython-to-me to get 5 or more offers with salary and equity presented right up front and a special listener signing bonus of $4,000. You can find the links from today's show at talkpython-to-me.com/episodes/show/18. Be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You can also find the iTunes and direct RSS feeds in the footer of the website. Our theme music is the song Developers, Developers, Developers by Corey Smith, who goes by Smix. You can hear the entire song on our website. This is your host, Michael Kennedy. Thanks for listening. Smix, take us out of here.
Stating with my voice, there's no norm that I can feel within. Haven't been sleeping, I've been using lots of rest. I'll pass the mic back to who rocked it best.